Maybe your boss says you need to learn about VLANs, or maybe you put yourself on this networking journey. Either way, I'm Brian Forget, and it's time to talk about VLANs. A VLAN, or Virtual Local Area Network, is not a virtual switch, but what it is splitting up a switch into multiple broadcast domains. Let's get into it. We gotta talk about the past, the way things were once upon a time. So let's get drawn. Little Brian, check. Let's say that you bought some switch to plug a whole bunch of computers into. Let's just draw our 1980s looking computers here. Delightful. Let's get some more of those. All right. The more computers we plug into it, we're gonna be okay, unlike a hub, right? Every port that we plug into is its own separate collision domain, so everybody can still talk at the same time. But all of those devices are going to be able to talk to each other when we plug them into the switch. Which, first off, you say, great. But for one reason or another, whether it's for policy or technical reasons, it is often the case that you do not want all of your different computers or hosts to be able to talk to each other. Policy reasons. Maybe it's that the development team is working on whatever project and you need to have that separate from sales and everybody else because they don't need to know about that yet. Maybe it's for technical reasons, like you're getting into storage area networking, something like iSCSI. And very often in iSCSI, you need to have two dedicated separate networks from each other for multipathing between your servers and that storage. Or various other technologies where, like we said, policy or technical reasons, you need to have different separate networks, different separate broadcast domains. Well, if I bought this switch and I plug all these devices into it, they can all talk to each other. Well, like, that's not that big a deal because, like, maybe what I do is I want to just split it out and have, okay, half my devices talking to each other over here and half of them talking to each other on that other switch. Great, no problem. I've got these two separate broadcast domains. We'll come back to that. These two separate, we could say, networks. But to do that, I just bought a second switch. But I might have still had a lot of ports available on that first switch, right? Let's say I got something like this 48 port switch here. And I've only plugged in half my ports, and I've got other networks, other broadcast domains I need to get access to. I got half my ports still sitting here empty. I don't want to have to buy another switch just to split things out. That is the problem that a VLAN solves. Right there. There's other subtleties for sure, but it's basically that. It's you need to be able to split up a switch into multiple broadcast domains. Very similar to the idea of different networks, because you don't want to buy another switch just to have a different set of broadcast domains. All right, well, how does that work? Let's get into it. Going back to it, I'm just going to have one switch here for a second, and this is a little bit of a review of where we were at the other day. I'm just going to come in here and label a few things, give everybody MAC addresses. Again, there'd be 12 hexadecimal characters, but let's just lie and say they got MAC addresses A, B, C, and D. And gives more down here, E, F, G, and H. Something like that. And let's just clean up our ports here. I really kind of shot myself in the foot giving myself this many devices, but it's fine, it's fine, it's fine. Okay, so we said the other day that when we have switches trying to talk to each other, see if I can make the font a little bigger here. There we go. That if they're plugged into that switch, that it's going to use its MAC address table to learn which MAC is on which port, and then forward traffic only to the appropriate port, as long as it knows where the destination is. So we're going to go fill in our MAC table. Let me just label some ports here. We'll say these are 1, 2, 3, and 4. And come on down here. And Again, shot myself in the foot making this many ports, but whatever. 5, 6, 7, and 8. So our MAC address table for here, we said we're going to keep track of our MAC and our port. Match our colors here. There we go, something like that. All right, and then as each of these computers send messages, maybe computer A there is pinging over to computer, doesn't matter, H. Well, sure, let's do that. Let's make some message. We'll say that it's a ping, and we'll wrap that up. It'll be ICMP echo request, but whatever. And we'll wrap that up in IP. And it's going to be from whomever's IPv4, IPv6 address to the other one's address. Now, I didn't label them here, but let's just go give an address of 10.0.0.10/24. Move you on over. And H, I'm not going to count that out. We'll just say it's 10.0.0.20/24. All right, so from source address 10.0.0.10, and destination 10.0.0.20. Okay, that's my IP header. Let's make a little more space here. Right, and over at Ethernet, encapsulation, something like that. Okay, cool. And at Ethernet, it's going to be sourced from A, destined to H, we're imagining here. Okay, and again, Ethernet, gonna wrap that whole thing up, give it a little footer too for the CRC at the end. A little checksum value at the end of the Ethernet. Okay, and that whole message, when we're sending a ping, wrapping it up inside of IP, inside of Ethernet, that whole thing's gonna happen on the computer before it sends, right on your computer at 10.0.0.10, before it sends it over to mine at 10.0.0.20. That whole message then gets converted into pulses of electricity or light or RF or whatever if it was Wi-Fi. In this case though, pulse of electricity sent down the wire, hits that port 1. Port 1 looks at the address and says, first off, did I learn anything? And it's gonna write down the source or destination? Yeah, the source MAC address and which port it came in on. And so in this case, our switch 1 would have learned that MAC A is apparently over there on port 1. All right, now it's going to say, where do I send this? And it's going to check the destination and then check its MAC table to see if it knows where that destination is. Destination is H. If this is our MAC table, nope. We only know where A is at this point, we've imagined. Well, that's fine. We said it'll send it everywhere except the port that it came in on. It's called flooding. This is what will happen always for broadcast traffic. For unicast, one source, one destination, if the switch doesn't yet know where the destination is, it treats it like a broadcast. It floods it, sends it everywhere except the port that it came in on. Okay, and so in this case, everybody gets a copy of the message, and everybody else, B, C, D, E, F, G, whatever, all the other actual MAC addresses of the host there, those other hosts will just throw it away. It's not to them, it's junk mail, it's fine. But your actual, or pardon me, my computer over here gets the message and it says, yeah, I'm MAC H, and it looks inside, right? I'm 10.0.0.20, and it looks inside, and there's that ping, right? And if my firewall's not blocking it or whatever inside my host, sends it up to the ping app, and reply comes back. Okay, when the reply comes back, it's going to be from my IP address back to yours. I can put that in there. And it's going to be from my MAC address back to yours. I'm just going to redo those. From, what did we say, H back to A? Okay, and it's going to refigure that out through something called ARP we can talk about later time. Okay, and that's all happening over here inside my computer. And then that gets sent up the wire, hits port 8, and the switch says, well, the source is H. And it writes that down. Somebody with a MAC address of H just sent a letter, right? Sent an Ethernet frame out, and it showed up on my port number 8 there, so switch 1. And so I'll write down, if I'm ever looking for H again, I know they're on my port 8. Boop. And then it checks the destination. It says, do I know where that is? A. Yeah, A's right there. And so instead of sending it to everybody, the switch can send it directly back to your computer on port 1. Okay, that's where we were at from last week's video about an Ethernet switch. That's the basic way of Ethernet MAC address learning right there. Fundamental. That stays important for everything else. But today we're talking about VLANs. Why is that helpful? Well, we said that I could take this switch and split it potentially up into a bunch of different broadcast domains. Broadcast? We were just talking about broadcast, right? We said that a broadcast is when you send traffic out every port but the one it came in on. Okay, that's a broadcast. Send traffic out every port but the one it came in on. There is broadcast traffic. That would be from my source, my MAC address, your MAC address, to everybody. In fact, there's a dedicated broadcast MAC address. The dedicated broadcast MAC address is, purple here, ff:/ff:/ff:/ff:/ff. That is a reserved MAC address in Ethernet. Should be 12 characters. And that's only used for sending messages to everyone within your broadcast domain. I like to remember that because it's like the computer saying, where should I send this? And it like tried hard not to say a bad word. So that's the broadcast MAC address. And so any traffic to that MAC address is always going to be sent to everyone except the port it came in on as far as the switch is concerned. But we said also that if the switch doesn't yet know where a MAC address is, hasn't learned it yet, that it'll flood it as well, treat it like a broadcast. And this is the basic way a switch works. And once upon a time, like we said before, this is the only way a switch would work. And so everyone on this computer would always get flooded traffic, if it was going to be flooded, from everybody else. But we said a minute ago that the problem we're trying to solve is the ability to split up a switch into multiple broadcast domains, kind of like a network. So that we're saying these sets of computers can talk to each other without going through a router. We'll talk about routers in a later video as well. But a broadcast domain is where a broadcast can be heard. A classic switch or an unmanaged switch is a broadcast domain. If I take another switch and plug it into this first one, can I rearrange stuff slightly? Yeah, that'll work. That'll work. Okay, if I take another switch and plug it into this first one without doing anything else, let's call it switch 2. Okay, then I've just extended my broadcast domain. Yeah. This is just some cable I plugged in between those two things. Maybe these are both port number 24. You know, I'll change it to 23 and 24 just to show that they don't have to be plugged into the same port number. And some cable plugged in between these two things here. Well, that switch over there is going to have its own MAC address table as well. And let's see if I can move this. That'll do. There we go. It's going to have its own MAC address table, just following all those same rules. It's not going to communicate between the two switches, the control traffic in this way. It's not like when switch 1 learned that MAC A was on port 1, it tells the other switches. Nope. That switch just has its own MAC table as well. And if traffic happens to show up on one of its ports, it writes down, is it the source or destination? The source, yeah, it writes down the source back and which port it came in on, and it populates its MAC table. It checks the destination in that Ethernet frame and floods it if it doesn't know, or sends it to the right port if it does. And so that same rule is happening over there. But if we want to split things up into different broadcast domains, well, that's again where this idea of a VLAN comes in. So I'm going to get rid of our second switch again for a second. So let's keep things simple. And let's just say that we want half of the ports on here to be in VLAN 1 and half of them to be in VLAN 2. Just to have different numbers. There will be a number associated with a VLAN. It's some number between 1 and I'll just go ahead and say about 4,000. Technically it's 4,094, but for practical reasons, a lot of times you don't use the ones above 4,000. Okay, so about 4,000 VLANs. You pick some number, you associate it with it, and then that is a broadcast domain on the switch. And so we said maybe half the ports in one VLAN, half in another VLAN. Well, let's change it up. Let's change it up here. I'm gonna get rid of my whole A and H thing for the moment. And okay, that'll work. Let's also change things up a little bit, just so we'll say that all the ports on the top here, 1, 2, 3, and 4, are going to be in VLAN 1, and we'll say all these ports on the bottom, 5, 6, 7, 8, are going to be on VLAN 2. All right, so you would log into this switch and create a second VLAN. By default, all managed switches, that's not fair, almost all managed switches will have a VLAN configured by default with all the ports associated with it. And then if you wanted a second VLAN, you would configure that second VLAN, tell the switch about it, and then you would associate some ports, leave them in that default likely VLAN 1, and other ports, move them into another VLAN. Next week, or next video I should say, we'll get into actual configuration. But for the moment, what we're gonna do is we're gonna come in and let's just use some colors here that I haven't used yet. Let's say, here we go, that ports 1, 2, 3, 4 are all on VLAN 1, like we said. Let's just go label. And we said that all of our ports down on the bottom, 5, 6, 7, 8, are going to be on VLAN 2. Let's pick a color that probably works for everybody's eyes. Yeah. Not beautiful and perfect here, but that'll work. Okay, and so how is the switch gonna keep track of that? Well, again, you log into it and configure it, but what's happening behind the scenes? Through the cunning use of another column in the MAC address table, the switch can not only learn what what MAC address was the source, what port it showed up on, but also what VLAN it was. Just writing it down based on what you would have configured on there. So let's change things up a little bit here. Let's have it be A talking to B. Let me give it an IP address here. 10.0.0. I want to make this one 20 /24. Okay, and clear things out here a little bit. Doop. Let's clean it up over here a little bit. So let's say it's your computer over on A talking to my computer on B. You got the address of 10.0.0.10. I got that address of 10.0.0.20. I got that, or pardon me, you got that MAC address of, we're lying and saying A instead of actually 12 hexadecimal characters. And I got that MAC address of B. Okay, and you send that, this all happens inside your computer, and that little message comes down the wire, hits port 1. We cleared out our MAC address table here, right? So we're starting fresh. And so again, that switch is gonna learn that the source MAC of A just showed up in some Ethernet message. It was marked as your MAC as the source, and it came in on its port number 1, and it was apparently VLAN 1. I wrote it down. And then the switch checks the destination. Destination MAC is B. Remember, a classic switch doesn't care about IPs. Destination is B, and so it checks its MAC address table. And at this point, we're imagining doesn't know where B is. And so we said earlier, it's gonna flood it, treat it like a broadcast, send it out every port except the one it came in on. Right, and that's the thing. Except we're gonna modify that slightly, because when we broadcast, when we send out traffic out every port except the one it came in on, and we're gonna add in here within that VLAN. That is what happens on a managed switch, on a switch that's capable of handling VLANs, that we're only going to flood traffic out all the ports within that VLAN. And so in this case, when switch 1 here sees this message to MAC B and it doesn't know where B is yet, it sends it out every port but the one it came in on within that VLAN 1. And so now, yeah, everybody gets a copy of that message who's got a port in that VLAN. And all the computers over here that aren't in VLAN 1, they don't get a copy of that message. They're not getting bothered. There we go. Computer C and D and whoever else in VLAN 1, they say, well, that's not my Mac, right? That's to Mac B, I'm not Mac B, and so they throw it away. My computer gets a copy of it over here, Mac B 10.0.0.20, and says, yeah, that's my Mac, and it looks inside. Yeah, that's my IP, and it looks inside. Yeah, you know, firewall's allowing that, pass it up to the ping app or whatever, right? And then just like before, now my computer is going to respond and say, yeah, I'm going to send this ping echo reply back from my 10.0.0.20 over to your 10.0.0.10. From my Mac A, in this case, I just lied. From my Mac B, in this case, back over to your Mac A. Builds that whole thing, right? And then sends it out of its NIC down the wire, hits port 2 of that switch. And what does the switch learn? Well, it looks at the source Mac. It says, yep, Mac B is apparently on my port number 1. Move that down a touch. There we go. On my, I just didn't want to get, I'm lying. I'm messing you up on port 2. And it's apparently also in VLAN 1. And then it says, okay, well, that's what I learned from my source. How about my destination? Destination is A. Do I know where A is? Yeah, A is on port 1. No problem. And so the switch sends this message only back to you on port 1. Comes up the wire, right? Your computer says, yep, I'm Mac A, I'm 10.0.0.10, and yeah, I got my ping back, right? Cool. And so this is what's going on between the two. Meantime, the switch now just learned that A is on port 1, VLAN 1, B is on 2, VLAN 1. If C and D, either of them want to talk to either computers A or B, well, cool. Like, as soon as they send some message, switch 1's going to learn their Mac, and then see the destination is A or B, right? And it knows right where to send that. Okay, how about these computers down here? 5, 6, 7, and 8. Ports 5, 6, 7, and 8. E, F, G, and H. Well, let's give them some IP addresses as well. And let's see here. I'm going to say that they have IPs of 10.0.20.10/24. What? Yeah, I'm making that pretty different, aren't I? So I'm going to give that one to E, and I'll do H over here as well, and I'll make that 10.0.20.20/24. All right, and we can make that work. Let's say that here's a message from, get rid of our fields here, boop, from 10.0.20.20 over to 10.0.20.10. And from Mac, apparently H, over to Mac E, apparently. H to E. All right, so here we go. It's from that guy over there's computer, right? Not our computers, that other guy over there. Talking to that other gal over there. Okay, this message is made on that computer. Tiny little copy of it here to send up the wire, right? Comes up the wire, hits that port number 8, apparently, and switch 1 over here says, yeah, I just learned that if I'm ever looking for it again, that Mac H is apparently on my port number 8 and VLAN 2. Yeah. And then it says destination is E. Let's check our Mac table. Does the switch know where Mac E is yet? A, B, H, nope. And so we flood it. We send it out, treat it like a broadcast, every port except the one it came in on, within its VLAN, within its broadcast domain. And so, yeah, everybody within VLAN 2 gets a copy of this message because we don't know where to send it yet. But we don't send it out anywhere that's not in our VLAN 2. Okay. Now, F and G all get a copy of it. F and G say, nah, it's not for me, right? That's not my destination Mac. But E over here says, yay, that's mine, right? And it looks inside. Yeah, and that's my IP address. I'm 10.0.20.10. Did it right? Yeah, okay, good. And now I got a ping message. Echo request, probably. Okay, and the reply comes back just like before. And when the reply comes back from that computer, I'm not going to do the whole thing this time. But now it's going to be from E back to H, right? From our 2010 back to our 2020. And that message comes up the wire and it hits port 5, and just like before, we'll just fill this part in here at least. Now it would know E is on port number, what did I say, 5, and VLAN 2. Oops, light brown. Boom. Ah. Okay. Right. And in this way, the switch is able to have these two separate broadcast domains, almost as if it's two separate switches. It's not. One switch, one MAC address table, but again, through the cunning use of another column, it's able to keep things separated. Excellent. Okay. This is one switch. If we have two switches, that's going to change things up. Let's get a little more room to work here. Just making things a little bigger. The magic of a digital whiteboard. Okay, so what I'm going to do is I'm going to make another switch again like we had briefly before. And I'm going to cable them up. Plug them into each other, and just like before, at least I think I did before, I'll plug port 24 of switch 1 into 23 of, I should label it here, switch 2. Now, there's no reason port 24 can't get plugged into port 24. I'm just picking different numbers to show you can, and also so that when we look at the MAC address table of switch 2, it's easier to keep it separate. All right, we got switch 2 over there. Let's get some 1980s looking computers. Just draw new ones. Something like that. And we're just going to get a couple of them over here for quick. And we'll plug them in. Boop. Boop. And let's give MAC addresses. MAC X and MAC Y. Definitely not hexadecimal, but whatever. There we go. And let's just label those port numbers. We'll say these are plugs into port number 1 and doesn't even matter 2. All right. What we can do is we can set up our same VLANs over here on switch 2. I can have those ports, maybe port 1 on VLAN 1. Port 1 certainly doesn't have to be in VLAN 1. I'm just being consistent. And we'll have port 2 this time in VLAN 2. Let's see who's doing this light brown. Okay. And now I've got a question for you. Before I draw anything else, any MAC addresses or anything, or MAC address table for this switch 2, pause if you need to, but ask yourself, can X and Y talk to each other in this network, in this topology? Are you back? No, they would not be able to talk to each other, X and Y. Yep, they're port 1 and 2 of that switch 2, but if they're in separate VLANs and you don't have a router that we'll talk about in a later video, they would not be able to talk to each other. But we could set it up so that computer X over here in VLAN 1 could talk to everybody else in VLAN 1 back on switch 1. And that computer Y over there on switch 2 in VLAN 2 could talk to everybody over back on the original switch on VLAN 2. How do we do it? Well, we've only got one cable between these switches right now. We could technically hook up a second cable, a second set of ports, and have VLAN 1 on one of those ports and VLAN 2 on another port cable. But for various practical reasons, you're not going to do that. I mean, you kind of can, but you're probably not going to do that. Probably. What you're going to do is you're going to set up these ports that are connecting these switches as something that's often referred to as a trunk. A trunk. And we'll get more and more into this on the next video when we get into configuration, but very generally speaking, if you're talking about a trunk port, that is, generally speaking, a port with multiple VLANs. It can refer to other things, but at least classically, a trunk port in Ethernet is a port with multiple VLANs. How do you have multiple VLANs on one single port? You know, port number 24 there on switch 1, 23 over there on switch 2? Well, what you do is, if you're going to have more than one VLAN on a port, all but one of those VLANs must be tagged. What? Yep, tagged. The other option is untagged. Doesn't have to have a capital T, just my emphasis. And what it comes down to is a tagged Ethernet message literally is an Ethernet message that writes down the VLAN number in the Ethernet header. That's it. That's it. A tagged Ethernet message. The VLAN number, or ID, or number. Yeah. Pick a different font. There we go. Tagged. The VLAN ID or VLAN number is written down in the Ethernet header. Untagged, I think you're on the right track already here. The VLAN ID is not written down. That's it. Everything I've described up to this moment has been untagged traffic, because literally in the Ethernet header, there wasn't a VLAN. You might come across the term 802.1q. I'm going to write that down for you. Make it purple. 802.1q is an IEEE standard, an industry standard for VLAN tagging. And there's this 802.1q literally would be a part of the Ethernet header. It's an extra, I should have checked this first, I think 12 bytes, if I remember correctly, in the Ethernet header before, outside the IP. And in there, this little .1q, do capital, there is a VLAN ID, say VLAN number. And there's also a priority value, 0 through 7, but we're not going to worry about that right now. Yeah. If you have a tagged Ethernet message, then when the Ethernet switch or your computer goes to make that thing, wrap up your ping or HTML or, HTTP, whatever Ethernet traffic, whatever traffic you're going to send out the wire, when it gets around to the Ethernet header, if it is tagged, then your computer or that switch or router or whatever is going to just add a little more in the Ethernet header to mark down the VLAN. That's it. And so in port 24 over on switch 1, we would be able to say, for instance, that untagged, oops, picked yellow, untagged, the VLAN is 1 on that port 24, and tagged, it's VLAN, what is it on, 2. The other end of that cable over there on switch 2, we would need to match that so that the tagged VLAN is 2 and the untagged is 1. Okay, well, how does this work? Let's go back to our computers A and B. And we'll just wipe out our MAC table here. Whoop, whoop, whoop. And I'm going to rearrange things slightly. Put you down. I'm going to move this text down as well. And let's make another MAC address table for switch 2. And let's label these. We'll say the one over on the left is switch 1. One over there on my right is switch 2. And let's say the computer A, your computer, is going to send another ping back to my computer, Mac B over on port 2, but we've cleared out our MAC table here. And let's get rid of this VLAN ID. We don't need that at the moment. Because the thing I didn't say before is that all of these ports with just my laptop or your laptop or some printer or whatever, almost certainly your computer and mine don't know what VLAN they're on, and they're not going to be able to write that down. The switch is going to have all those ports configured as untagged for our VLAN. All right. So when your computer sends this, I got it this way. So my computer is going to ping yours from B to A, apparently. So when my computer sends this message out from 10.00.20 to 10.00.10, more importantly for the switch from Mac B to Mac A, and that comes down the wire and hits port 2, apparently, then my switch 1 is going to learn Mac A, I'm just going to leave these on black for the moment, is on, oh, I just said A. Mac B, sorry, is my source, is on port 2 and VLAN 1. And then when destination is A, and we're imagining now my switch 1 doesn't know where Mac A is, we said it's going to flood it. Go look, treat it like a broadcast, send it out every port except the one it came in on within that VLAN. Okay, cool. Just like before, then it's going to send it out port 1 and 3 and 4 and anywhere else in VLAN 1, including port 24. Yeah, everybody's going to get a copy of this. Boop. Everybody but me that's in our VLAN, including a copy of that going out port 24 on my switch 1 over to switch 2 on its port 23. And does switch 2 learn something then? Yeah, it's going to look at the source, the source MAC address. And it's going to say, oh, well, the source MAC in there, copy of the same message, is B. And it showed up on my port 23. This is why I gave them different numbers, because it doesn't know it's the other end of the cable. It just says switch 2 on my port 23 is where that showed up. And it came in as untagged. And because I've got port 23 over here set up as untagged 1, that means anything that shows up that doesn't write down what VLAN it's on, it's going to assume that that is VLAN 1, because that's the untagged VLAN on that port. And then it checks the switch 2, says, let me check the destination. It's A. Do I know where that is? If not, flood it. Send it everywhere except the port it came in on. So it's not going to send it back out 23, but everybody over here within that VLAN is going to get a copy of it. Right now it's just that one computer X, and it's not for them. Okay, everybody else who wasn't Mac A, though, threw it away, and your computer over there with Mac A is going to respond, hey, I'm Mac, look inside and respond back, presumably. And when it does, that message is going to come down, hit port 1, and that switch 1 is going to learn, oh, yeah, Mac A is on port 1, on my VLAN 1, and doesn't know where Mac B is already, the destination for the response. Yep, it's on port 2, and so no problem, it can deliver it directly back to port 2 without bothering everybody else. Meantime, if computer X over there wants to send a message to your computer over in MAC address A, well, it didn't know where to send that. It would have to flood it. But if it wants to send a Mac B, my computer, yeah, no problem. It can send that right back out. It's port 23. Okay, let's talk about VLAN 2. So let's say, here we go, that 10.0.0.20 wants to talk to 10.0.20.20. All right, well, that works fine. Yappy. Paste. There we go. Let's not worry about the IPs. I don't want to make you wait. Max, we'll write that in. This Mac, was this E to H? Actually, heck, let's go big. Let's go over to Y over there. The other switch. So let me give it an IP just for kicks here. We'll say it's 10.0.20.100/24. Okay. So that's who we're sending to. I'm just not writing down the IPs here to save time. Okay, from E to Y. And this message, copy of this thing, borrow one of these, comes up the wire from over here. Mac E comes up, shows up on port 5 over there. All right. And switch 1 is going to learn, yep, I'm on it. Mac E is apparently on its port number 5 and on VLAN 2, because that port was apparently marked as untagged for VLAN 2. And so any messages coming in over there without the VLAN written down in that .1q header, it's going to just assume it's VLAN 2. And it's going to check the destination. Scroll on down. Destination is apparently Y. Does it know where Y is? Check our MAC table. Nope, doesn't know. So it sends it everywhere except the port it came in on and within that VLAN. And so, yeah, we flood that message out to everybody else. To computer over there on, oh, that's funny, on computer F and G and H, right? Out ports 6, 7, and 8, and port 24. All our computers over here, they just throw it away because they're not Mac Y or whatever, actual Mac, right? But when we send it out port 24, the switch is going to need to do something because VLAN 2 is tagged. And so before it sends this copy of the message out of that port number 24, it's going to need to modify it. It's going to need to add in a VLAN ID, an 802.1q value. And that VLAN number is apparently VLAN 2. And so, yeah, when it goes to rewrite the Ethernet header, before sending it out that port, real quick on the fly, that ASIC, yay hardware, is going to rewrite the header, recalculate the checksum as needed, and send it out with the appropriate VLAN. And that is what's going to go out port number 24 over here with that VLAN ID. That is what shows up on port 23 on the far side. And when that shows up on port 23 over there on switch 2, it says, yes, source is E. And so, yeah, I'm going to write that down, right? If I'm ever looking for it again, switch 2 says MAC address E is available on, apparently it's port number 23. Notice we've got more than one MAC on that port. That's fine. That's okay. And it's on VLAN, because it sees the VLAN ID, 2. Yeah. And then that switch says, oh, do I know the destination? Destination is Y. Let me check my MAC table, says switch 2. I know B. I know E. That's it. And so it floods it. It sends it out every port except the one it came in on within its VLAN, which might be a bunch of ports. But in this imagining, I only put 2 ports and they're different VLANs. So I guess it's going to send it out port 2. And if port 2 has been configured, like it likely would, as untagged for VLAN 2, then that message, when it's copied over to port 2 to be sent out, it is going to, if VLAN 2 is untagged over there, it's going to rewrite the Ethernet header before it sends it out so that there's not a VLAN tag. Because your computer, or whoever's computer is over there, is not expecting it. And so that message, when it's copied over to port 2, in this imagining, if it's untagged 2, it's going to strip off that VLAN tag before it delivers it, sends it out the wire, pulses of electricity or whatever, hits that computer, and it says, yeah, I'm MAC Y. Yeah, that's my IP. Yeah, I'll accept ping. Yes, and so in this way, if we're talking about tagged and untagged VLANs, tagged VLANs are used to allow more than one VLAN on a single port, like 24, like 23. Untagged VLANs are often used when it's going to some end device, a host like your laptop, your printer, some device that doesn't know what VLAN it's on, doesn't need to know what VLAN it's on. We're going to have an untagged VLAN on that port so that whatever traffic comes in from your computer, the switch knows what VLAN to associate it with in its MAC table. And when we send traffic out of that port, it only comes from other devices within the broadcast domain in this case. As far as Ethernet's concerned, and we'll strip off that VLAN tag before we deliver it to you, just in case your NIC is weird. This is something I've run into in the past, less often now, but occasionally, the vast majority of the time I will say, a network card that receives a tagged Ethernet message that is not marked for expecting tag, will just ignore the VLAN tag and be fine. Sometimes, every now and then, I've run into it where they just disregard the message, though, saying, I'm not doing VLAN tagging, I don't want that, and just throw it away. So yeah, you want to have untagged messages delivered to hosts that aren't expecting a tag. Okay, last little bits. Tagging you think of as per link. I like to think of VLAN tags as existing on the wire. That on this link between those two switches, yeah, I got VLAN 2 is tagged and 1 is untagged, and that's going to get it between those two switches. But on some other cable that's going down to your computer, on that link, yeah, probably untagged. And so it's decided effectively per link, whether you're tagging or not. You also want to match your tagged and untagged VLANs. If VLAN 1 is your untagged VLAN and 2 is your tagged VLAN over here on port 24, then you want to match that on port 23 at the other end of that cable, or whatever port you're plugged into on that switch. Different switch operating systems will have different ways of doing this. Maybe it's a graphical only interface, GUI. Maybe it's command line for Juniper over here and HP over there, or Cisco over there and Dell over there. As long as it's Ethernet, yeah, you might type very different commands in on switch 1 and switch 2, but as long as the untagged VLANs match and the tagged VLANs match, you're good. IEEE standard on the wire with that 802.1q VLAN header. Anything else? Last thing. more than 2 VLANs. You can almost certainly have as many VLANs as you want on that link. And if you're doing that, it will be one untagged VLAN and then as many tagged VLANs as you want. Now, some switch specific models or operating systems might have limitations to say, well, on this, not as expensive device, you can have 100 VLANs on each link or 1,000 VLANs on each link, or about 4,000 VLANs on each link. It just depends on the exact thing you've bought. But in practice, probably as many VLANs as you want on there. But again, one untagged and as many tagged as you want. We'll get more into that later. And the next one, don't technically have to have an untagged VLAN. You could have all tagged between those switches. You're just probably going to have a single untagged and multiple tagged. And that'll make more sense later when we get into spanning tree and Cisco. So here's where we're at. Why are VLANs a thing? What problem do they solve? It's because you got a switch, but you need more than one broadcast domain. And so you want to split that switch up into multiple broadcast domains so you can use all those ports. It's so that you can have some link from that switch over to another one and extend those VLANs, those separate broadcast domains on that link over to it. That's where you get into the idea of tagged and untagged VLANs, so that link might have more than one VLAN on it to extend those broadcast domains to the next switch. All right, everybody, you rock. This continues to be a blast. Do me a favor. If you're out there, let me know in the comments what you're looking for next. This idea actually came from TechDweeb Discord. Someone calling out saying that they needed to learn some VLANs, so I bumped this up in the list a little bit. So let me know what you're looking for. Let me know what I can help you with, and I'll start checking those the comments to see if y'all have any questions or something that you might need a hand with. I'll see what I can do to help out. Thanks, everybody. Like, subscribe, and I'll see you next time. I'm like 90% sure this is what he was talking about. Right? It's a switch, right?